this example, we're going to look at how to solve an exponential equation. Again, the variable is in the exponent, where we cannot write both sides using a common base. 15 and 285 cannot be written as the same number to different powers. It's not going to work here. So that approach doesn't quite help. So the first thing that we're going to go ahead and do here is we're going to take the logarithm of both sides. I'm just going to use the common logarithm because I'm going to go to my calculator eventually to evaluate this, and that's going to make it easier for me to do that there. So if this statement is true, 15 to the 3x is equal to 285, that's what this says, then this statement would also have to be true. The logarithm of 15 to the 3x would have to equal the common logarithm of 285. Again, if this original statement is true, which we're to assume, that's what it says, this equals this, then log of this thing on the left would have to equal the log of this thing on the right. Now that we have this written with logarithms, we can take advantage of one of our properties, where we have that power property of logarithms here, where I have log of 15 to the 3x power. I can take this 3x power, I can move it down in front of the logarithm connected by multiplication. So that this becomes 3x times log of 15 is equal to the log of 285. Now, going ahead to solve this, I could divide both sides by just 3 log 15 all at once here. I'm just going to go ahead and try to create an approach, remove the logarithm, and then continue to solve the remaining equation because it might not always be able to be done in one step, so I'm going to show it that way in this problem. So the first thing I'm going to do here is try to get rid of this log of 15. I'm going to do that by dividing both sides by log of 15. That would cancel, and I need to do that over here as well. And that would leave me with 3x is equal to whatever log of 285 divided by log of 15 happens to be equal to. So now I'll go ahead and go to the calculator and compute that so we can see what that's equal to. I'm going to go down here to log, so common log 285. Make sure you close the parenthesis after that number, or else you'll be incorrect because of that. Divided by the common log of 15 is equal to 2.087291136 approximately. So there's how we evaluate that with the calculator. So now that I've evaluated that into the calculator and I've got this number a little bit larger than 2, I need to go ahead and finish doing any remaining steps of algebra to solve this equation for x. In this case, that's just dividing both sides by 3. So I will divide this by 3, and at that point I will know what x equals. So I need to go back to my calculator. I need to finish this off by taking this answer that I got from the division of the two logarithms, doing the remaining step of algebra where I divide by 3, and then I'll finally have my answer to this question. And I think this question is asking me to round to the nearest 10,000th, so that's 4 decimal places in its directions. So let's go back to the calculator. Next step is to divide by 3, so I just need to finish this off by taking this and dividing by 3. And I should arrive at my answer to this question. So I see 0.695763712. And this question has asked me to round to the nearest 10,000th, which is 4 decimal places. So I'm going to look. I've got 1, 2, 3. Here's the 4th decimal place. I need to look at the 5th decimal place after that. And I see that this 6 being 5 or higher is going to force this 7 to round up to an 8. So I should have 0.6958 for my solution to the nearest 10,000th to this exponential equation. And that's how you do that.